We're going to go through a few exercise examples here just to tie everything together and hopefully hammer things home. And we're going to start off with a bicep curl. I know that we've already gone through this, but we're going to go through it in a little bit more detail. So hopefully it's still helpful even though we've already done it. So with the bicep curl, first let's figure out which muscle group is working. So again, step one for that is just figure out during this exercise what happens if I just completely relax. And of course the answer is if I just relax, gravity is going to pull my elbow into extension. So because of that, we know that the active muscle group is going to be the muscle group that does the opposite motion. So it's going to be the elbow flexors. The elbow flexors are going to be on during the entire exercise for both the concentric portion and for the eccentric portion. Whereas the antagonists, the triceps, they're not really going to be on at all. They're just going to be relaxed the entire time. Now, when figuring out which type of contraction is occurring, again, when the weight is moving up like this, that means that the muscle is causing the motion. So it's a concentric contraction and the elbow flexors are on and they're shortening. Since the muscles are moving up against gravity like this, we also know that the internal torque or the internal moment is greater than the external torque because the internal torque is overpowering the external torque, causing the weight to move up. Now on the way down, the opposite's occurring. So the way down, this motion is being caused by gravity, just pulling the weight down. So in this case, the elbow flexors, they're not causing the motion, they're just controlling the motion so that the weight doesn't flop down like this. So elbow flexors are controlling it, which means it's an eccentric contraction. The elbow flexors are on and they're lengthening. And in this case, the external torque is overpowering the internal torque because the external torque is larger than the internal torque. If we were to hold this as an isometric contraction here, we could just hold it like this, and then gravity would be trying to pull me into elbow extension, but the elbow flexor muscles are preventing that. So there's no motion, there's no change in length, and this is an isometric contraction where the internal torque is equal and opposite to the external torque. Last thing with this exercise, we can briefly talk about moment arms. So remember that moment arm is the distance between the line of force and the axis of rotation, and the moment or the torque is the product of the force and the moment arm. So during the bicep curl exercise, when my hand's just hanging here by my side, we can use this cane as the representation of the line of force. So here's the line of force going straight down through my hand, right? And you can see that this line of force is really close to my elbow. It's basically just running through the elbow joint. So because of that, there's a really small moment arm from gravity, and gravity's pulling down on my forearm, but it's not really trying to cause elbow extension. So I can kind of just let my arm dangle here. My biceps don't really need to be on very much because there's no external moment arm. My muscles just can kind of relax. On the other hand, when I'm at 90 degrees of elbow flexion like this, now gravity is still pulling down on my forearm, but there's a much bigger moment arm because it's pulling down way out here instead of down here by my side. So out here, let's say that this is the line of force again. So now there's a big moment arm between the line of force and my elbow joint. So there's a big moment arm that gravity is acting on. Therefore, there's going to be a big external moment. So my muscles have to work a lot harder in this position, and it's just harder for me to hold it here.